In this video, we'll focus in on the different sensors that we use to actually measure pressure. And there's quite a few different sensors, and these sensors are used for different things depending on whether we're measuring, for example, atmospheric pressure or our absolute pressure, differential pressure, and they use different mechanisms to sense these different pressures as well. Here we're primarily talking about liquid and gas pressure measurements rather than solid ones I talked about previously. Now, some of the gauges, like the one above, have multiple units on them. They might have printed on them bar and PSI, or pascals and bar, or something like that, for example. Some people are used to different types of units, and some units are more commonly accepted within industry for different quantities of pressure that are trying to be surveyed. I mentioned again those common units of pascals and PSI and atmosphere, bar, and two other common ones of inches of mercury and millimeters of mercury as well. We also have different ranges that we want to measure pressure over sometimes. Sometimes we have very high pressure applications. Sometimes our pressure applications are quite low, and that will allow us to determine what sort of sensor is suitable for the sort of application we're after. Now, we have a few basic types of pressure sensors and a few basic types of outputs for those pressure sensors. The most common one that we might see around the place is probably a mechanical gauge, an analog gauge that we can actually see. We can see, just like in the previous slide, an indication of what the pressure is. As the pressure increases, the gauge shows a higher number. But we can also have a digital gauge, just like the one above here, which some of these allow you can press the button and you can cycle between PSI and bar and different settings like that. We can also have outputs from our pressure sensors, for example, as an analog voltage or a digital voltage or some sort of a digital readout, just like. Now, there's some common actual measurement techniques that we use to actually measure this pressure. Things like a diaphragm, things like a bellows or a Bourdon tube. And each of those allow us to measure the actual pressure. Now, we can have different outputs based on each of these techniques because we can use our mechanical gauges like what we have on our previous slide, or we can have digital readouts and electronic interfacing to each of these as well. Particularly useful if we want to be recording pressure and logging it over time, for example. Now, here's some internal pictures of some of our mechanical gauges. Our diaphragm, our Bourdon tube, and our bellows, and how the actual needle in these is connected to the movement of our bellows or our Bourdon tube or our diaphragm in these cases. Now, I saw a video from a pressure sensor manufacturer that shows how these different pressure sensors work internally and how they're actually made. So you'll watch that as one of the follow-up videos to this. But let's think for a moment about some of the applications of these pressure sensors before we get into the deeper details of how they actually work. Now, there's lots of applications in medical areas. Things like measuring blood pressure or intracranial pressure, pressure build up within our skull, or pressure in maybe infusion systems where we're trying to give patients blood or give them antibiotics and things like that. There's lots of applications in transport areas as well. Looking at pressure of brake fluid and engine oil and lubricants and all of those sort of things, making sure that our drive systems and our suspension systems are working within their required range. We also have the areas of heating, ventilation, and air conditioning, making sure that we're actually pushing enough air out, particularly when we've got a building with multiple points of sensors and heating and cooling. We need to know that we're supplying enough pressure, particularly to those endpoints, the ones furthest away from our blowers and our fans and our heaters. Pressure sensing is a big thing in process control, measuring how much of a liquid or a gas that we're supplying to something, making sure that we don't increase our pressure too much, because sometimes chemical reactions will change based on pressure and temperature and various characteristics like that. Likewise with instrumentation and scientific research, where we're often looking at trying to perform experiments at particular pressures and particular temperatures and trying to standardize those across our different experiments. Equipment that uses pneumatic systems and hydraulic systems heavily rely on pressure for movement and stability, for feedback and for control. We use pressure heavily within aviation and also underwater. Underwater, we're looking for leaks and things in our ROVs or our submarines and trying to maintain various levels of buoyancy or neutral buoyancy. Within our aircraft, we use pressure for altimeters to work out how high we are above ground level, because our pressure changes as altitude increases. And we can use pressure in mining when we're doing drilling or extracting of things from the ground. Ensuring we have pressure there, we can ensure that we can detect leaks and things, for example.